Okay, so let's move to the question number 2 of the D block elements. So this is saying that the ion which shows the maximum paramagnetic character among the bivalent ions of the first transition series. Okay, first transition metal series. So you can see that these all ions are bivalent. Okay, why bivalent? Because they are containing the +2 charges. Okay, so and these all are the elements of the first transition metal series, that is the 3D series. Okay, so we need to check it that which one has the maximum paramagnetic character. Okay, so you should have one clear point in this regard, that what is the paramagnetic character. Okay, so if the elements or if the ionic species having the unpaired electrons, okay, if this is having the unpaired electrons, okay, unpaired electrons, or you can say unpaired d electrons. All right, so you will say that this is your paramagnetic. Okay, paramagnetic, it means it is susceptible for in the magnetic field. Okay, so let's see how to do this question. So first of all, you need to write down the normal electronic configurations, and then we will show. Okay, so let's see that if you say the what is the electronic configuration of cobalt, so you can say it is the 3d7 4s2, right? If you talk about the copper, so it is 3d10 4s1. Okay, chromium, it will be 3d5 4s1. Okay, for iron 3d6 4s2, right? And for manganese it is 3d5 4s2. Okay, so we did all the electronic configuration of these elements. Now let's make their dipositive ions. So if you talk about the cobalt +2, definitely it will lose the 2 electrons from the fourth shell. Okay, so this will become the 3d7. This copper +2 will become the 3d, 3d9, right? It will become 3d9. This chromium +2 will become 3d4. Okay, and iron +2 will become 3d6, and this will become manganese +2 will be 3d5. Okay, so if you draw the, you can get some idea till now, but let's explain all the things. Okay, seven electrons, so 1 2 3 4 5 6 7. Okay, so unpaired electrons are 3 unpaired electrons, right? And 3d9, whenever you do the 3d9, so 1 2 3 4 5, so 1 2 3 4 5 6 7 8 9, right? So this is your one unpaired electron. Okay, similarly if you talk about the 3d4, so there will be 4 unpaired electrons. Okay, 1 2 3 4. All right, 4 unpaired electrons, and here we can say how many? 6. 1 2 3 4 5 and then 6. Okay, so these remaining 4 are unpaired electrons. Okay, now here you can say there are 5 unpaired electrons. 1 2 3 4 5. 1 2 3 4 5, right? So here you can say that there are 5 unpaired electrons which are present over there, okay, which are present there. Okay, so that's how we solve this question. And so you can conclude here that the manganese plus 2, okay, this one, this manganese plus 2, this bivalent ion in the 3D metal series, this will have the maximum number of unpaired electrons. So that's why it should have the maximum paramagnetic character, okay. This should have the maximum paramagnetic character because more free electrons are available. Okay, in this way you can say that it will have the maximum paramagnetic character, okay, maximum paramagnetic character. Okay, so that's how we solve this question. So its answer should be last one, manganese plus 2. Okay, let's move to the next question. And what is the next question? Okay, let's discuss this particular complex, and this is your complex, okay, complex compound. That is the question number 4th. Okay, which of the following complex compound will exhibit the highest paramagnetic behavior? Okay, so the concept will be same. If the species have the unpaired d electrons, then we can say that it is paramagnetic, and if it is not having the unpaired electrons, then it will be the diamagnetic. Okay, it will not be a paramagnetic species. Okay, so how to understand these kind of the complex compounds? So firstly, just write their normal electronic configurations, and just focus on the center metal atom. Okay, so if you take the first this one, so here you can say that this is your titanium plus 3. Okay, because the ammonia, okay, whenever you talk about the oxidation state of this center metal atom, so ammonia you will take 0. Okay, so the overall charge which is present on this complex, that will be the charge on the center metal atom. Okay, so you can write here that this titanium will be in the titanium plus 3, and this chromium will be chromium plus 3. Okay, this cobalt will be cobalt plus 3. All right, and this one, if you take this is quite interesting because we have this ionization sphere. Okay, so firstly we need to ionize this, and how to do this thing, you can write here that this will be your zinc NH3 whole 4. Okay, zinc NH3 whole 4 plus 2 and 2Cl negative. Okay, so here you can say that zinc is present in the plus 2 state. Okay, all are present in the plus 3, and this is your plus 2. Okay, so let's see that how to understand which one is having the more unpaired electrons. Okay, so titanium plus 3, chromium plus 3, if you write the electronic configuration. Okay, so here I can write the electronic configuration. Titanium, you know, normal titanium is having the scandium titanium. Okay, so this will be 3d2 4s2. Okay, right, and chromium, you know, chromium is 3d4 4s2, right, this will be your electronic configuration. And cobalt will have the 3d7 4s2. Okay, 3d7 4s2. And zinc will have the 3d10 4s2. Okay, this will have the 3d10 4s2. Okay, so in this way you can now let's talk about the given species. Okay, if you have the titanium plus 3, so definitely it will be lose the 3 electrons, so it will become the 3d1. Okay, chromium plus 3, chromium plus 3 will become 3d3. Okay, 3d3, right? Cobalt plus 3, it will become the 3d6, right? This will become yours 3d6. And zinc plus 2, this will become the 3d10. All right, so that's how we solve the electronic configuration. So now let's see that which species having the more number of the unpaired electrons. Okay, so this one will have the one unpaired electron. Okay, this will have the one unpaired electron. Okay, this 3d1, it means one unpaired electrons. Okay, and here we have the three unpaired electrons, and here how many when you write this one, so 3d6. Okay, let's see, 1 2 3 4 5. Okay, and then 6. So how many? 4 unpaired electrons. Okay, and here we have 0 unpaired electron. So that's how you can see that the option number C is our possible answer, because it is having the maximum number of unpaired electrons, that are the 4 unpaired electrons. Okay, so in this case you can say that this complex should have the highest paramagnetic behavior. Okay, this should show the highest paramagnetic behavior. Okay, so that's how we do this question. And let's see if some other question like this we can solve here. All right, so okay, so then we next questions we will solve in another video. Thank you.